this lesson, you will learn to make inferences and justify conclusions from an observational study. If you flip a coin 50 times, how many times would you expect it to land on heads? You'd expect it to land on heads about half the time, or 25 times. If I told you I flipped a coin 50 times and it landed on heads 30 times, would you be suspicious of my coin? How many times would it need to land on heads in order for you to be suspicious? I performed the 50 coin flip 100 times and graphed my results on a frequency table. Given the additional information, what do you think now about my coin landing on heads 30 times? The general feel of where the possible values land is somewhere between 22 and 30, perhaps even 21 to 30. The big idea is that we have a known expected value. In our case, it was the expected number of times the coin would land on heads, 25. Given that value, we can determine a set of possible values that might occur under random circumstances. Since we wouldn't expect to favor heads more than tails, or vice versa, we would expect the red bars to be evenly spaced from 25, so maybe from 20 to 30. For our purposes, it is sufficient to understand that what we are looking for is a range of values that could occur given that the coin is fair. The chance of falling within that range is about 90%. However, it is more interesting to consider the chance that I fall out of that range. Only about 10% of time would I expect to get a value of more than 30 or less than 20. Therefore, if we get numbers outside of that range, we would consider it rare. So, if the coin were fair, I should get numbers within my shaded region. If you flipped the coin 50 times and got 33 heads, then that's pretty rare and the coin might not be fair. But if you flipped the coin 50 times and got 21 heads, that's still possible. It's a lot more likely, so the coin is probably still fair. In statistics, the idea of finding the probability and associating it with a cutoff for rareness is called a significance test, and the entire process is referred to as inference. We can infer results based on our observations. You can learn more about this if you take AP Statistics or a college statistics course. For our purposes, we do not need to calculate the value, but rather have an understanding that there exists a measurement that can help us determine possible values that frequently occur from a random chance. Let's look at an example now of rolling a fair die and see what we can infer about the possible outcomes. A die was rolled 30 times, with the outcomes listed in this table. For a fair die, each number 1 through 6 has an equally likely chance of occurring when the die is rolled. So, if the die is rolled 30 times, we could expect the side with 6 dots to appear 1/6 of the time. 30 divided by 6 is 5, so we would expect the die to land on 6 dots 5 times out of the 30 rolls. From the frequency table, we can see that it is common to get a 6 as few as 3 times, or as many as 7 times. Therefore, anything outside of those amounts you might consider weird, and infer that the die was not fair. Let's think about a few situations that might occur with our die. Based on the graph below, what is the expected number of times a 6 occurs? Well, according to our graph, the number of times the 6 dots appears is most likely to be 5. Since that is the amount that occurs most often. What is the range of values that would be considered possible for 30 rolls, assuming the die is fair? According to this frequency table, we could expect the number 6 to show up as many as 3 times or as many as 7 times. So our range would be between 3 and 7 times. What if a new die is rolled and a 6 appeared 9 times? Is the die fair? We can see that it's possible for a 6 to appear 9 times, but it is not very likely. It could be possible that the die is not fair. What if a new die is rolled and a 6 appeared 3 times? Is the die fair? For a 6 to show up on the die 3 times is within our likely values, so the die is still probably fair. Now it's your turn. A fair spinner is spun 30 times, and the number of times it lands on blue is recorded in this table. Draw a line on the expected number of times the spinner will land on blue. Then draw lines on the boundaries of likely values. What could you say about a similar spinner if you landed on blue 14 out of the 30 spins? What could you say about a similar spinner if you landed on blue 6 out of the 30 spins? Pause the video to work out the following problem. Click play to continue. Let's look at how we could solve this problem. In this situation, the expected number of times the spinner will land on blue appears to be 8 times, because that is the amount that shows up most frequently. The expected possible values will be evenly spaced around 8. Looking at the frequency table, we can see it is very likely to occur as many as 12 times. So to keep the possible values evenly spaced, it could also occur as few as 4 times. So the expected number of times the spinner will land on blue could be anywhere between 4 and 12 times out of the 30 spins. If a similar spinner were to land on blue 14 times, this would be very unlikely. It is possible that the spinner was not fair or that there was some interference. If the spinner landed on blue 6 times, this is not as likely as 8 times, but it is still within our possible values, so we say that the spinner is probably fair, or that we do not have evidence to believe the spinner is not fair. In your notes, please make sure to write down the purpose of inferences and the procedure for inferring and finding the range of possible values. The purpose is to infer whether a model is consistent with expectations based on results from a simulation. And the procedure is to run the activity multiple times to collect data. Based on that data, determine the range of values that could exist. Using your results, determine if you believe the assumptions about your model are consistent. In this lesson, we have learned to make inferences and justify conclusions from an observational study. See you in the next lesson.